Welcome to my YouTube channel. Today we will learn about Ohm's law. So let us start. In beginning of the Ohm's law, I will discuss some terms which are related with the Ohm's law, which is the part of current electricity. So first term is the conductor. So what is conductor? We know in conductor by definition we can say conductor are those materials through which heat and electricity can pass easily. That is the conductor. Now what we know about the conductors, in conductors there are the free electrons. Free electrons are there, and free electrons are in random motion. They are moving in random directions, means no specific direction is there. Now it is the first diagram, and in second diagram I have connected it with a battery or source of EMF, battery or cell. So in this case what will happen, all the electrons will arrange, they will move in particular direction, specific direction, due to potential difference. So as we apply the potential difference, these electron will move in a specific direction, in particular direction. That is about the conductor. Now as we say here electrons are going to flow. Electrons are flowing in a specific direction, and we know as the electron are flowing in a particular direction, so we know the flow of electron is nothing but charge. So what is charge? Simply charge is the flow of electron. So it is the flow of electron, and charge is given by Ne. Q is equals to Ne. Here N is the number of electrons, and E is the charge on electron. So we can write this formula as Q is equals to Ne, where again N is the number of electrons and E is the charge on electron. And we know what is the charge on electron. Charge on electron is minus 1.6 into 10 raised to minus 19 coulomb. Unit is of course coulomb. Unit of charge is coulomb, and it is represented by C. Now here as we mentioned, electrons are going to be flow in a particular direction. So as electron is flowing, so charge is flowing, but if the charge is going to flow per second, whatever amount is there, then that will be called as the current. So current, we can define the term current. Current is the rate of flow of charge, that is charge upon time. We can write the definition. It is the rate of flow of charge. Now one very important term I will tell you, if in physics this rate word comes, it means that term will be divided by time. So we are talking rate of flow of charge. So it is charge ka rate, means charge per unit time. So it is the current. And we can write current as the charge upon time. Charge is Q, time is T. So I will be Q by T, but Q is Ne. Earlier we say upon time. So this is the formula for current. Since charge is NE, we can write over here. Next term is resistance. We have heard about the resistance. Why? What is resistance first of all? So simple way we say, in any conductor there are the free electrons, and as we apply the terminal potential difference across them, so electrons collide with each other, and due to collision electrons oppose their motion. It means there is the opposition in the flow of electrons, so we can say there is the opposition in the flow of charge. It means there is the opposition in the flow of current. That is the resistance. So once again, what is resistance? Simply, resistance is the opposition offered by the conductor to flow of electron, to flow of charge, or to flow of current. Any of the term we can choose. So again, I will discuss about this diagram. Here we are observing electrons are going to flow in a particular direction, and electrons are very compact to each other. In case of conductors, so they collide with each other. As they are moving in a particular direction or a specific direction, they collide with each other, and due to that, they oppose their motion. That causes resistance. So this is the basic concept of resistance. So we can write simply, what is the resistance? It is the opposition. It is the opposition offered by the conductor to flow of electron or charge or current. It is the opposition offered by the conductor to flow of electron or charge or current. Any of the word we can use. Now, next thing, already we have mentioned what is the reason for the resistance, what is the cause of resistance. So simply, we have mentioned resistance is a rise in any conductor due to collision of electrons. So cause of resistance we can write, it causes due to collision between electrons. It causes due to collision between electrons. Now unit of resistance is ohm. Unit is OHM and its symbol is this, omega. Greek word we call it omega. Now next term is the potential difference. Potential difference. Of course, it is the difference between two potentials. Difference of potentials. We know about the battery. Battery having two terminals. One is the positive terminal, another is negative terminal. Positive terminal is called higher potential and negative terminal is called lower potential. And there is the difference between higher potential and lower potential. That difference is called potential difference. When we say the battery get discharged, higher potential and lower potential, there are the two potentials. This upper part is higher potential, lower part is lower potential. So as we use the battery through any circuit, so that difference comes equal to each other, and as that becomes equal to each other, it means battery get discharged. It means potential difference becomes zero. Both the potential becomes same or equal. So this is the positive potential positive potential and this is the negative potential. So potential at A is VA, which is higher potential, and potential at VB is lower potential, and difference is the potential difference, or simply we can write it sometimes PT, that is simply V. So this is the concept of potential difference. Simply we have to remember it by the observations of practical. Battery, when battery get discharged, when their potential becomes equal, positive and negative potential. Now we have to discuss about the main topic, that is the Ohm's law. What is Ohm's law? We will learn Ohm's law by one observation. And what is that observation? Let us see. Very simple observation. We experience it in day-to-day life. That observation is here in front of you. Just we have to think about this observation and we will conclude Ohm's law. So let us see. I have drawn two diagrams. One is this, another is this. This is the bulb, and this bulb is connected by a single cell. And this bulb, the same bulb, is connected by two cells, which is called battery. Number of cells is called battery. So what is our observation in first diagram? We see that as single cell is used, brightness of the bulb is less. And here number of cells we have increased, it is 2, means potential difference increases. So brightness of the bulb become more, it means more current is flowing. So as we increase the potential difference, current also increases. This is the observation. What I said, as we increase the terminal potential difference, current also increases, so brightness increases. So we can write the conclusion of the observation over here. In this case, as it is the conclusion, as potential difference increases, there is increase in the brightness, there is increase in the brightness. So current increases, current also increases. It means what conclusion we can say? Potential difference is represented by V. It is directly proportional to current I. Why directly proportional? Again I am telling, as here we are increasing the potential, here current also increases. So one increases, another also increases. So what is the relation between these two? That is directly proportional. So potential difference is directly proportional to the current flowing through the conductor. This is the basic observation of the Ohm's law. Now we have given the statement of Ohm's law, and what is that? Simple way, if the physical condition of a conductor remains unchanged. Physical condition means what is the meaning of physical condition? Length of the conductor, like wire is there, that's length. As length is more is the resistance. Area of cross section, this part we can say this is the area of cross section. As the area of cross section is more, resistance will be less. So these all are the physical condition. Temperature of the surrounding, pressure, these all comes under the physical condition. So once again, what is the statement? If the physical condition of a conductor remains unchanged or same, then potential difference across the end of the conductor is directly proportional to the current flowing through the conductor. So whatever we were discussing observation, that we can write here, we are getting potential difference is directly proportional to the current if the physical condition of a conductor remains same. That is, we can write V is directly proportional to I. So V is equals to I into R, where R is the proportionality constant, which is called resistance. So we can write where capital R is the proportionality constant, which is called resistance, Now unit of resistance is ohm. Unit of resistance, what it will be? Since R is V by I, so it is unit of volt is volt only, potential difference, and unit of current is ampere. So it is volt per ampere, or it is simply ohm. Now how we can remember, how we can learn the formula? V is equals to IR. It is so simple. Just we can add to memory by this triangle diagram, whatever I have drawn. So in this case we can write it is V, it is I, it is R. So as we have to calculate V, in this case, we have to calculate V, so definitely it will be I into R, this. So we can write it as V is equals to IR. Next is, as we have to calculate I, so definitely that will be V divided by R. So next term is I is equals to, it is V by R. Next term, if we have to calculate R, then for calculation of R, it will be V divided by I. So next conclusion is R is equals to V by I. So this is all related with the Ohm's law. Thank you for watching this video. Please like, share and subscribe my channel. Thank you.